Hello, I'm Andy Brown. I am the editor of International Construction magazine. And earlier on this year, I had the pleasure of speaking to Graham Grant, the Chief Executive Officer at Seequent. So, Seequent work in a few different sectors, including mining, engineering, and civil. Some very basic terms. The company creates and integrates earth modeling, geodata management, and team collaboration software. So they basically help us to understand better the world beneath our feet, the subsurface. The company are actually part of Bentley Systems, and I first met Graham last year at Bentley Systems Year in Infrastructure event in Singapore. I was really impressed with Graham. He's a very passionate and informed speaker, and he was talking about topics such as the importance of the subsurface world in terms of the energy transition, which is obviously happening all around the world, and obviously for that transition we need certain materials which are in the ground, and also the growing importance of subsurface construction. With only so much space on planet Earth, the construction industry may well be working underground more than ever before in the future, both in terms of building structures, but also in terms of making sure the foundations are there for these kind of buildings, which are growing ever and ever higher. My first question to Graham was asking him to describe the company and the solutions that it offers.
Well, thanks, Andy. Seequent's a world leader in software that helps organizations understand the underground. Now, we joined Bentley about 2 years ago now. Now, the underground or the subsurface can have a huge impact on the success of infrastructure projects because of all the unknowns that we can't see. So that might be something like unexpected shallow groundwater that makes its way into a subsurface project. It could be that you're driving foundations and expect to reach a competent rock layer that's just not there, and you need to drive those foundations further. And all these things can create huge delays and cost overruns. Now, recent research found that these unforeseen ground conditions is one of the top 10 reasons globally why that drives these overrun claims on these big infrastructure projects. So with a much better understanding of the underground, you can create a shared understanding, you can uncover risks and communicate them, you can collaborate appropriately, and ultimately for the whole project, just achieve a better outcome. Andy, every industry is needing to adapt, and the construction industry is no different. Now, AECOM recently published their research in the Energy Transition Survey that pointed to issues around the cost of equipment and the cost of technology, higher energy costs, and just lack of access to renewable energy and effective energy storage. Now, over 70% of those 850 executives interviewed said for more progress, they needed access to affordable renewable energy, because the infrastructure business runs, and industry runs on very, very thin margins. So the question might be, well, how does technology help? Well, earthworks are a huge component of any project and a huge part of the carbon budget, both excavation and movement. And so then the question might be, well, if that's the case, does all this need to be moved? And if so, does it need to be moved as far? Now, Mott MacDonald on the HS2 rail project in the UK used Seequent and Bentley digital twin technology to understand the underground to an earlier point and to communicate that across partners. Now, this resulted in a massive reduction in the material moved, the material dumped, which means less fuel and less time. Now, the projected outcome from their pilot study is staggering in terms of sustainability. Estimated savings of thousands of hours of construction time and 250 million litres of water. Well, this is all down to mining, an industry we are deeply involved in fact, where we started. And this includes, of course, critical minerals, which leads to the metals we need for all of these transition energy activities. So as a simple example, an EV car, now that we're all very familiar with, will consume 6 times the weight of critical metals than a conventional vehicle. And you can scale that up across all of the electrification activities. So this is a big change on the demand side. Now, on the supply side, there's an emerging problem. So, for example, the battery factory that will produce the batteries for that EV car, the gigafactories, they can be now constructed in under 12 months. The mines to supply those metals will take between 15 and 20 years to enable. So there's an example of a huge timing mismatch between demand and supply. And what we are trying to do is help the mining companies more quickly find and extract those metals on a sustainable basis. Now, the good news is that there is a lot of innovation happening on the energy front, such as ground-sourced heat, which we are also very involved in. That can be heat for power. It can be heat for industrial processes. And most recently is the emergence of naturally occurring hydrogen, something that we're keeping a very close eye on. In fact, just 3 days ago, the BBC reported on this huge find in northeast France, where that singular naturally occurring hydrogen deposit, they estimate is something around 250 million tonnes of hydrogen, which at that scale would be enough to supply all of the global supply for the next 2 years. The point is, we should expect to see rapid innovation in the energy space that will simply change the current landscape. Oh, absolutely. I mean, global population's now around 8 billion, projected to grow to around 10 and then stabilise. But the urban proportion of that population by 2050 will double from where it is today to where we'll have 7 out of all 10 people in the world living in cities. Now, interestingly, the bulk of those will be within 100 kilometres of the coastline. So when you put all that together, that fundamentally changes how we think about infrastructure and will place huge demand on resources in quite a concentrated way. So if we look at a response to that, I think Singapore is a wonderful model. I mean, Singapore has essentially decided to go down as well as up. So if you look at something like their deep tunnel sewer system, there's 200 kilometres of network that carries water by gravity to 3 big central reclamation stations. They have developments in underground storage, underground transport. So, for example, the North-South Corridor links will drive the bulk of car movement underground. Now, this, as I said at the outset, this underground world is in many cases largely unknown. So 3D ground models like we can build in Leapfrog will simply become pivotal to any future infrastructure construction project. Well, clearly digital twins are pivotal in infrastructure for the design, build and manage processes. Now, we believe that a subsurface understanding must be hardwired into these processes for first-class infrastructure projects. However, the above-ground world of digital twins' goal is to be a very accurate representation of what will be built. That's just not possible underground, because underground we're dealing with natural systems, and our hard data, which is the samples, are often very limited. So in that sense, a geological model or a ground model is not truly a digital twin. So our focus here at Seequent is to access every form of data we can get our hands on to build the best possible representation of what's underground and build that understanding. And this is really exciting if you think about combining that with Bentley Systems' world-leading iTwin digital twin capability. Well, Andy, in 3 years' time, I would like to think the construction sector has made huge advances in embracing digital transformation. And of course, we'll see the rapid emergence of AI accelerating and assisting human work. But I also hope that we'll see a greater realization of the benefit of understanding the underground. And the outcome of that will be better projects, lower cost, less delays, less contention, and better resiliency in our infrastructure. Now, for all of that, Ground investigation needs to be recognised as a fundamental component of any high-quality project, which should lead, I hope, to a singular and persistent ground model joined up to the infrastructure design and management through the life of the asset.